Alright. So today I'm gonna try to write a language in C, right? Because like it's two things I wanted to do is to write a language and to try C a little bit more, right? Because I mean I've tried C for several times, but it just never sticks, right? Like I'm not sure if it will, but like it's used the purpose really well because C is really simple, and my goal is to like write a language to the degree at which I can write itself in itself, right? Like I can use this language to write itself. And the simpler the first language is, the easier I guess it's gonna be to rewrite it in itself, right? So I guess the very first idea, I actually have to know how do I compile it, right? I have Clang. Clang is probably installed in macOS by default, right? So I guess for now I'll not use any sophisticated build tools. I'll just do main.c, right? How do you do it? Int main, right? Return 0. Clang main.c output main. Okay, it works. Nice. However, I don't really like this file. Like I would want to write like for development I would want to run it without having this binary always in my directory, right? I guess like the most straightforward way is gonna be to do it that way. Main. And then rm main. Yeah, it worked. Nice. Nice, let's leave it that way. Actually, I want to create make file, right? Make dir. How do I do it? Make? Actually, not that familiar. Make file. Tutorial by example. Learn make files. I built this guide because I could never quit wrap my head around make files. They seemed a wash. What is this word? Covered or full with water? Okay. With hidden rule, okay, and esoteric symbols and asking simple questions didn't yield simple answers. To solve this, I sat down for several weekends and read never mind. And read everything I could about make files. I've considered the most critical knowledge. Actually, let me skill it. I've considered the most critical knowledge. Condensed the most critical knowledge into this guide. Okay, get it started. Why do make files exist? It's like a simple build system, right? Originally it was. Make files are used to help decide which parts of a large program need to be recompiled in the vast majority of classes C or C++ files compile. Okay, yep. As languages typically have their own tools, yep. What alternatives are to the make file? I don't care. The version and types of make. The variety of language make, but most of this guide will work on whatever version you're using, however specifically written for GNU make. Okay. Which is standard, yeah. All the examples work from make versions 3 and 4, which are nearly equivalent other than some aesthetic differences. Okay. Alright, this example. Hello, echo hello. Okay. First of all, for each example, put the contents in a file called makefile with capital M and in that directory. Okay, let's do it. Makefile. Fuck, what have... Touch. Makefile. Let's go. So we are defining the command, right? And it's like def. And here I would actually want to like copy this. Just like that. Yeah, that's pretty good. Let's write it. Clear. Make def. Okay, but I would want to rename it to make run actually. Run. Make run. Okay, pretty good, but I'm not sure if this like text. I want to output this text. Not make files must be indented using tabs and no spaces, or make will fail. Here's the output running above example. Yeah. This is a bit confused. Here's video. Okay. Make file syntax. A file consists of set of rules. A rule generally looks like this: targets, prerequisites, I guess. Command. Okay. The targets are file names separated by spaces. What do you mean? A rule. Okay. Typically, there is only one per rule. Are file names. Okay. The commands are a series of steps typically used to make the target. This needed to run with step, character, and space. Okay, so I guess I just like can name it in any way. It doesn't really mean file. The prerequisites are also file names separated by spaces. These files need to exist before the command for the target and for the target are run. Okay, these are also called dependencies. Yeah. Hello. Okay. Blah C, blah. C compiler, blah C, blah, okay. Actually, this is pretty cool. So I can make it that way, right? It will still work. But now it will require the file to be there, okay. Runs. Wait, what? More quick examples. The following make file automatically runs all three targets. When you run make in the terminal, it will build a program called blah in a series of steps. Make selects the target blah because the first target is a default target. Blah requires blah.o, so make searches for the blah target. Requires, so make search, yeah. Has not a better is run, okay. This is C compiler minus C command in the run because is then run because all of the blah.o dependencies are finished. Okay. The top C command is run. Okay, so it just like just runs the top the most top one, right? Hello NS, hello. Wow, Waggle's hard? Yeah, it's really hard. Okay. How are you doing, Ennis? Okay. No, it was so awkward. If you delete blah.c, all three targets will be run. If you edit it and thus change the timestamp to newer than blah.o, the first two targets will run. If you run touch blah.o and thus change the timestamp. Okay, I'm not sure like if I really care about this, right? Like that's not what I need. I mean it works now. And like it's enough for now. Like I have this like output of what it executes, but I guess it's alright. Same stuff. How about you? I guess I'm okay. Like I'm just trying to chill. I feel like I just like have this curiosity how is gonna be the experience of writing a language, right? Like I can imagine what the typical programming language consists of, right? But I never done it before. So I can't chill? What do you mean? Are you grinding ranked in chess? This would explain everything. Okay. Is printf a built-in function or not? Printf. Oh no, it's stdio.h, okay. Printf, how do I do that? Hello world. Yay! Yay! NS, I recreated the program you have invented. I lost 150 elo yesterday. Man, that sucks. When I get tilted, I can't stop. Today, by the way, today I played like a half an hour game in Rapid, right? Like each of us had half an hour. And it was so bad, like I started so good and at the end I just lost everything. Like if you're curious you can check in my profile, but it was like so upsetting. I literally lost an hour for this game and in the end I was just like devastated. It just felt terrible. When I get tilted I can stop, that's so true. That's so true. I remember myself playing Valorant, it's like I'm trying to limit my games but I just can't. You know, you get that I'll win the next one feeling. Yeah, you know how it's like, how it's easier to do. It's probably not gonna work for you the same way, but like you can find another ways to do it. Right, so you're like go in here and you just block website, right? So you like just block chess.com. And now if you like visit chess.com, it just doesn't work. And like to disable it you have to like go to settings, type scenes, you know, and it just like takes time and you're like, nah, I'll better just do something else. Why does it format in such weird way? I don't really like it. But I guess okay, I'm not feeling like changing the formatting settings right now. Oh, that's cool. Yeah, like you know you won't be able to resist, so you're trying to make it that way that you won't need to like resist, right? So you just like make it so it's really hard for you to play. Okay, we got print hello world. That's not what I want, right? I mean, it's pretty cool. But let's start with a string const file. And I guess the most logical way to start is gonna be to like create basic calculator, right? So like calculator is basically a programming language with its tokens and compile time, right? And I can gradually scale from it, like adding variables, loops, and so on. Try to take a break when I lose 2 games in a row from now on. It's actually, I guess, a pretty good idea, even like for your rank, you know, to prevent those lose streaks, yeah. Print hello world. Okay, so like the first program is gonna be like 1 plus 2, right? Really simple. Oh, my bad. What am I doing wrong? Wait. Oh, let's see. What am I doing even? It's const. I'm not sure if const is even a keyword. Int. No, it's not int. It's like, how do you do it? It's. What is a byte in it's literally a byte, right? No, it's not a byte. The fuck? How is it? How U8 type in int is gonna be? Like, it's char. Yeah. Char. Redefinition of file is different kind of symbol. The fuck? How to define variable in C? That's insane. C strings. Images. Why am I? What the hell was that? The fuck? Char array. Yeah, that's like pretty much what I'm doing, isn't it? Char file. Do I have? Oh, yeah. Wait, and it's. That's how it should be. Const. Oh, it works. Nice. But probably this one looks more readable, not gonna lie. Fuck, this formatting is just insane. Okay, now we got the program. What do? We have to create tokenizer, right? I guess that's like the most reasonable thing to do. I'm trying to understand what the fuck is going on. It's really simple. So I have a string, right? It's just like string. It's just like symbols, right? It's like 1 space plus space 2. My goal right now is to convert them into tokens, right? So I want to create an enum. How do you actually do enums in C? There's like there is no native support for enums in C, so oh there is. Wait, But it's like, yeah, it's like an emulation, right? Because it's, yeah, 1, 2, 3. Or is it? Okay, let's just enum token. Probably want it to be like, okay, let's just make it just token, right? And now it's gonna be either number or plus, right? Because like, there are two types of tokens here. It's number and plus. 1 plus 2 equals 3. Yeah, that's what we're doing here. Like, the job is to make the program doing that. Me understand maths, me coding master now. Okay. Okay, we got the token. However, we don't have a value attached to it right now, right? So we have a number, which like program will know that it's a number, but it doesn't know what number it is. So I want to rename this token to like token type. And token itself is gonna be a struct with token type and value, which is for now is just int, right? I thought about making it any opaque because it's void star, right? Because it like literally can be anything. But for now it's just int. How do I define struct? Am I doing something wrong? Must use enum tag to refer to type. What? Wait, what am I doing? It's the other way around. Wait. Int value. Wait, do I have to do it like that? Seriously? Why? See, enum instructs. Seriously? Can I make struct member be an enum? It can only accept numbers that are available specific enum. Enum are just the ints. You can have an enum as structure member, but it would be the same as having an int. Okay, but like, I want semantics of an int, right? It's like I don't care if it's number or not, I just want to, so it's like I can like treat it as something else in code. Okay, we got a token. So what are we doing now? We're making a loop. Actually, it's gonna be a while loop. While. How do we do it? How do I iterate over string in C? Until, okay, I guess like I just have to go one by one, and if it's like null terminator, I should just, is it called null terminator? Null terminated string. Yeah. Like if we reach null, then it's the end. Actually, for loop is better here. So int e equals 0. Condition. File I not equals null. Is it null like that? Probably yes, I guess. Expression I++. Then token. Tokens. I guess. Okay, I know that there are gonna be 3 tokens, so let's just make it 3. Must use struct tag to refer to type tokens. Seriously? Now, how do you... There is like a way to do it without referring to a struct. C define struct. There is a way, I know, there is a way. I remember it. Struct A. There is a way. Type def. The type def keyword is used to define an alias for the already existing data types. In structures, we have to use the struct keyword along with the structure name to define the variable. Sometimes this increases the length. Yeah, we can use type def to define. I'm not really like what the idea, like why? Why there is type def? Like why it can be the default behavior? But okay. And I also think it will fix the enum problem, right? Type def enum. Type def struct. Type def requires a name. Oh. Remove this. Yeah, pretty good. I guess that's how you do it. Okay, let's go back. So we got token here. I find it so weird, but people memorize this stuff. Memorize, you mean like 1 plus 2? What do you mean? Ah, how people? My bad. It's not memorization, like it's just an understanding. You don't memorize that 1 plus 2 is 3. You just know how math works and you just calculate it. This here it works the same way, right? I mean, to some degree it's a memorization, right? But still. Okay, so we got tokens. We're going through everything. If first of all we have to check if it's a space, right? If file equals space. Actually, you know, I can use the full power of C and just write it right here, continue. Yeah. Continue. It's gonna format it in a such weird way, but okay. Else. What are we doing else? I want... Actually, I don't need stdio.h, right? Oh, wait. Okay, let's do it other way around. Comparison between pointer and integer. The fuck? What do you mean? Huh? File I, my bad. It's... File I is like... Is it a pointer? Wait a minute, no way. Comparison between pointer and integer char and char star. Huh? Let me think. So, like file is a pointer, right? But then we're like using an index I, and it should not be. It points to the value, right? Should I do it that way? Wow, that's so annoying. 0. Let's just assume it's 0. I want to believe it's 0. Comparison between pointer and integer. Okay, it's the same problem here. File. Char. Oh, wait, my bad. Is that how you do it? Yeah, my bad. Because I need a char, not a string. Yeah, okay, pretty good. Now, I want, like, now the problem is to understand if it's a number, right? So, like, I have to take a char. Actually, it's pretty simple. Why am I even thinking about that? If file I is less equal than 0 and file I is less equal than 9. Okay, pretty good. Then token. Oh, I have to create Yeah, I have to create a stack, right? Not a stack, it's like just a counter, it's actually not a stack. Counter int last equals 0 last equals token. Actually, can I do it that way? Tokens. Oh, bad, wait, tokens. Expected expression, I can't, right? Token. No? Wait, how do you do that? Type. How? Wait. I need more examples. So they just straightly use it. Parent, wait. I need with type dev. I'm not sure if there's a difference, but I want to check with type dev. Student. It's just. This one looks much better. Yeah, I will. So I'm doing type equals number. Type number here. Type plus. Actually, it's token type number. Token type number. Value equals what? File I. File I minus 48, right? Which is like 0. Expression expected. The hell you mean? Expression expected. Oh wait. No, don't wait. The fuck? It's an array. It should just. It's already defined. Wait. Expression expected such and like unfriendly error. Token? No, not really. Okay, so I got tokens, right? 0. Last. I can see array of structs. That's ridiculous. Bodies A equals. Wait, no way, do I have to do it like type? No actual way. No actual freaking way. Okay, let it be that way. Last was fast. Actually, plus equal 1. Prefer this one more. And I want to do it here too, just to be consistent. Okay. Now this hopefully should work. Before that, there is even a simpler check. That's if it's a plus. If file I equals plus, tokens last type equals token type plus. Wait, what am I doing? Okay, pretty good. Now I should correctly tokenize it. I hope. I guess. Hopefully. Let's check it out. I should printf. What do I do here? C for char, right? It's not on decimal. Decimal. Here's gonna be tokens 0, tokens 1, tokens 2. And then I also want values for them. It's probably gonna be like that, right? Then where is, yeah. Dot type tokens 0 dot volume. Tokens 1 dot volume. Same thing here. Type. Okay, pretty good. Let's run it. Make run. 0 1 1 0 1. Value is weird. Wait a minute. 0 1 0 makes sense, right? Because it's like 0 1 0, so it's like number plus number, which is good. But what about value? 1 1 and 1? The hell? Volume. It's because I'm not like... Damn, is it like initialization problem? Because there is like garbage, right? That's how it works. C init. Actually, you know, I guess I want to just like chat with Gemini. Fuck, how do I ask it actually? Damn, what am I even doing? Wait a minute. Oh, I rebinned it. Wow. I added a bin to create new tab on command A, but it's already taken. Let's quickly fix it. Settings. New tab. Shortcuts. Yeah, here it is. Reset. How do I init an array of structs with 0 volume? As far as I understand, it is filled. By default, it is filled with garbage. See. Copy markdown, update, run. Actually, 0.7. The fuck, by the way, I'm streaming on chess categories, that's insane. That's my bad. Let's quickly change it. Oh, it's syncing. Category software and game dev. Save. Okay. Will it change? Yeah. Of course, you're absolutely correct. When you declare a local variable like tokens inside a function, it is allocated on the stack, and its contents are uninitialized. This means it holds whatever garbage data was previously in the memory location. Yeah, to initialize an array of structs or any array with 0 values, you have a few excellent options. This ensures every element in the array is 0 equivalent. Damn, that's so good. I mean, it doesn't make sense from syntax point of view, but okay, I mean, mechanically it's pretty good. The most common and idiomatic C way to 0 initialize an array at the time for its declaration is to use an empty 0 field initializer list. How it works? This is a feature of C called aggregate initialization. When you provide fewer initializers in the list than there are elements in the array, the compiler automatically initializes the remaining elements to 0. Why it can do it by default, like without this? By providing just... Oh, because maybe it's like performance scene or something. By providing just 0, you're explicitly initializing the first element to 0. And the compiler 0 initializes the rest. This works for all members of the struct. Integers become 0, floats become... pointers become null, etc. Yep. Here's the corrected code using this method. Become 0, 1, yep. Yep. Also, I fixed a small typo in your printf. You had tokens 0.value in the end. Oh, actually, yeah. Okay, now it explains everything. Yep, now it explains everything. Does it? Yep. But why it was... Oh, because it was... Yeah, because I didn't have this one. And I kinda love this printf. Let's use it. Right? Good. Good. It works. Primitive method. Mem set. Set of tokens. Not zero it out. Okay. For dynamic allocation, calc. No, thanks. I don't need the dynamic allocations for now. For now, I'm good. Now we have... Okay, let's encapsulate it in another function, right? No, but it will have to return an array. Okay, actually, it's okay, I'll just make it static. No, it's not. It's impossible to return an array, right? Void. Tokenize. Pointer. Oh, actually, it's just a string, right? Because string is already a pointer, which is gonna be how do I call it? Data? Not data. Source. Pretty good, I guess. SRC. Destination. Yeah, pretty good. Let's do it token 3. Oh, it's gonna be that way, dest. How do I actually do that? Like that, right? Destination 3. Index. Int index, I guess. And last. Okay, let's call it last for now. Tokens. Destination. Go here. Nice. Tokens. No, my bad. File. Tokens. Last. It should work. Call to undeclared function. Oh. Seriously? Okay. I mean, maybe it's good. No, that's not the problem. Wait. Call to undeclared function ISO C99 and later do not support implicit function declaration. The fuck? Hello, hello. Fuck, that's some bot. Okay. Actually, like, I have these bots spamming like this scam website pretty often, so I guess like I can just save it and then just add it to filter list, right? Okay, let's proceed. How do I... CD, okay. Do not support implicit function declaration fix available. The fuck? Declared here. Did you mean tokenize? Have I misspelled it? Yeah, I did. It was so simple. Passing const char 6 to parameter of type char star declare discards qualifiers. What the hell does it mean? Clear. Let's just start Gemini. What does following error mean? Oh, because it's const. In simple terms, the warning is a compiler telling you, you promised me that the variable file would be read-only by declaring it as const. However, you're now passing it to a function that expects writable. Oh, so I have like to say in function that it's constant? Seriously? Okay. Okay. I mean, maybe actually it's not, it's kinda even sweet. Is it really? No, it's actually, what's the point, right? If you like, I don't know. Maybe it's good, like, you can see that function will never modify the variable, right? Maybe it's actually good. Okay, it works. Pretty good. Now let's eval, right? Now let's create another function called eval. Eval. How do I do it? It's gonna be token source 3. Tokens. Oh, there is like also an AST step, right? Abstract syntax tree. Do I need it here? Probably not. But I will need it later, right? Like at the moment I'll add parentheses, that's like when I need it. Actually not, even the moment I'll add multiplication, that's already the moment I'll need it. Let's think. Okay, so we got an array of tokens. Now I need a tree. Right, so it's gonna be an expression. I need another structure. Type def, struct, expression. Is that how it works? Yeah, I guess so. It should make sense. Actually, Yeah. Okay, I need another enum called type def. Expression. Expression plus expression sign. How do so expression have like type and volume, right? So it's like expression type. Type. And here's gonna be expression type. Type. Then value 1 and value 2. Probably it's just gonna be A and B, right? Int A. Int B. Okay, pretty good, pretty good. Is it really? It's not gonna work. Because, yeah, because I need, so it can be either integer or either pointer to another expression, right? I can just basically do it like, what is the type of pointer? Size T? C pointer type. Int star. Yeah, so it's like for the... But what if it's... Oh yeah, I can do it like... Wait. Here's gonna be expression with capital E. And here's gonna be expression. A pointer. B pointer. Unknown type expression. I can't reference itself. I'm building actually I'm learning how to write. Now I'm at the stage of building an AST. How do I make it so A and B can point to int or another expression? C. Let's go. 0.7. Should I save it? Expression. That's an actual question. It gets right to, to the heart of what makes an abstract syntax tree a tree. Let's look at your current expression struct. Right now, what kind of mathematical operation can this struct represent perfectly? Could it handle 1 plus 2? What about... I mean, I know, like... Yeah. It can represent... the operations with one sign. To fix that, I need to make it so A and B can be either int or another expression. So let's focus on the requirement. A and B need to hold either an integer or another expression. In C, how can a single field instruct hold values of different types? Void star? No way. For instance, how could a variable x sometimes hold an int and other times hold a float? Wait, is it like... What's it called? I forgot the name. Union. It's union, right? Unions. C union. Okay, expression. Volume. Type def. Union. It's either int num or it's either expression pointer. Unknown type name expression. The fuck? It's because it's before. Do I have... Can I do it like without type def? On type expression. Okay, let's for now go here. What's it? It's expression value. And now the problem is, if I'm gonna pass it before, it will tell me it doesn't know what expression value is, right? Yes, exactly. Union is designed for a piece of memory to hold different types of data, different times. So let's think about the different shapes of data expression can have. It could be simple number, literal. What information do you need to store for a number? It could be a binary operation like addition. What information do you need to store for that? Yeah. This one is good. Let's create another new chat. Clear chat. How do I fix the error that... How do I fix following error actually? See. Looking at the code, what's happening online? What do you think? It is because it's like it's way too picky actually. I created this one so it can like not give me straight answers, right, and just like guide me so I can find the answer myself. But this one is way too picky. It is because an expression is defined after expression type, but I can't put it other way around because expression type uses expression to, I guess something like that. Shouldn't be that bad. Circle dependency, yeah. You're correct that you can't simply order them, so let's think about what the compiler line really needs to know at a specific point. When compiling the line inside your union, does the compiler need to know the full layout of expression struct? Does it want me to use void pointers? Like, does the compiler need to know the full layout of expression struct, its members, its total size, etc., or does it only need to know something simpler about expression just to create a pointer to it? Does it really want me? Do you want me to use void pointer for that? No way. No more. How do I say it? Clean way to do that. Circular dependency. C struct. Circular dependency. The way to do this is to wait, I'm not using pointers? Do I? Wait. No, wait. Expression value. Yeah, it's a pointer, I guess. I'm not sure actually. Probably not a pointer. Expression. I'm confused. Robin. The way to do this is to predefine the structures in empty definition. Wow. Wait. Wow, what? Wow, wait, what? Struct B. What? That's a very clever thought. Using void would indeed solve the immediate compilation error, but you're right. Of the special, let's explore that. What the downsides? Okay, actually, you know, I just want to copy it and go to like normal Gemini. Pro. 0.7 run. The solution. Forward declaration is a pointer. Change this to a pointer. Wait, what do I have right now? full fix code. Step 1. Forward declare the expression struct and create the type def. This lets the compiler know that expression is a valid type name. Wow. Wow. Okay. Type def redefinition. Huh? Oh. Okay. Expression. Okay. That's so wild, but okay. Yeah, and now let's build the tree. How do I do that? I got the tokens. Right, I got all the tokens. So what do I do? Let's create another function called void. Wait, what am I doing? Void build ast. Tokenize is capital. Is it how it should be? It probably should be a lowercase, right? It's like a C. Build. Should be. How do you write it in C? C function naming. C naming conventions. Public function. So it's snake case, right? Prefix, 2 or 3 letters, model prefix. Private functions. Title case, okay. Local variables. I'm not sure about this one. Use whatever convention I prefer. My preferred convention is lowercase without underscores for short and fires and snake case for long ones. Yeah, I would probably use Zeek convention, right? So it's like title case with first letter lowercase. How do I call it? Naming convention. Yeah, that way. Okay. Build ast. Tokens. Damn, I need dynamic memory allocation for that. At this point, it's already just feels so full, actually, not gonna lie. How do I create slices like in Go and C? Generic slices. Is it possible to build a generic slice? Colon like generic slice type in C. It should be possible, but my guess would be that it requires macrosys, right? Because I mean, I've already tried it to do at some point, and it's like insanely hard. And doing like create type for slice of each type is like ridiculous. It's gonna be so unclean, so dirty. Fat pointer, yeah. Dynamic growth, type yep. Fat pointer struct that represents our slice. It's analogous to Go's internal slice header. Yeah. Data, pointer to underline read data void star here. So I see len, capacity, element size, the size of single element. Okay. Slice. But like it will. Oh, helper macros for type safe ergonomics. A more convenient way to create new slice for specific type. Slice new. wait. Slice new, size C. Type, size of C. Okay. Append the value, not a pointer to the slice. This macro handles taking the address of temporary variable. Slice append, slice C, const element. Append a new element to the slice may be reallocated. Element must be a pointer to the data to be copied. Okay. But it's like, it's void pointer, that means like there is like no real type safe here, right? The after type temp value. This one is crazy. Slice append. Slice pointer temp. Okay, well. Okay, this one should be pretty safe actually. Gets a value from the slice and casts it to the correct type. No, this is not an L value. You cannot assign to it. So unreadable. Let's try. Slice get, slice pointer. Slice get. Wait. Slice get. Returns a pointer. I always have to put... Oh, it's index. Yeah, my bad. I thought it's like a type size. Return a pointer to the element at the given index. Return null if the index is out of bounds. So we cast it into the type. Okay, pretty good. It's like a typecast. Oh, but I have to put in... It's so ridiculous. Slice new. Slice make. Slice free. Slice append. Oh, it was a .h file, right? It was header. Yeah. Example usage main.c. Print slice, wait. Slice, in slice, slice new. Int. Oh, it's so bad. C, generic array list. Make a generic array list in C. It looks like you're pretty close, but there were some function. Generic collections in C. I use both. Okay, wait. A simple example would be a generic dynamic array. Do you use macros to generate the various functions and structures required for each concrete type, or do you use type ratio and treat data as blocks of memory? As both, no real preference, just depend on the goal. I prefer generic templates from the user perspective, but I hate having to read or write them because of all the macro shenanigans you have to deal with. Plus my eyes just get tired reading a ton of all caps identifiers. I hate you. This article got me to move away from the function macro style and instead use defined type style generic templates, though it looks a bit messy because of the defines and you lose the function syntax, which I think is more obvious to read, but it makes it a bit easier to deal with the template itself, both when writing and debugging. Templates in C. It's like C++ templates. I don't really know how C++ templates work. Define. Max AB. If A more than B, return A else B. How long it is? It's actually not that long, let's read it. It's 2022, it's pretty fresh. Sometimes I see people on the internet sharing their generic libraries in C. More often than not, they turn out to use some giant macro. Yeah, that's like my experience and it's just terrible. This generates a huge amount of code on a single source line. I thought I would show a better way of doing it if you need to write some C and don't want to copy paste yet another dynamic array or hash table. None of these ideas are new. I am sure people were doing this in the 80s, but not everyone is aware of them. Yep. No, generic, underscore generic has nothing to do with this. Also, you could use it to simulate overloads if you generate a lot of code. I don't know what is that. Generics in C. There are a few ways of creating generic data structures or algorithms in C. Void pointers, yeah. If the data you are working with can be coerced to a void pointer, you can sidestep the problem by writing a single implementation that only works with void pointer or only with raw bytes. Yeah. When the user actually uses it, they have to cast back to the original type and to be careful not to get confused about which data structure is which. Yeah. This is easy to implement. Okay, actually, let me scale for stream, because like for me it's pretty big, but on stream it's really small. 200. Yeah, pretty good. Where I was? Yeah, when the user actually uses it, the castback. Yeah, this is easy to implement, but it's error prone and type unsafe to use. If you require all data to be pointers, the user is encouraged to heap allocate a large number of individual items, which is bad for performance. Yeah, function pointers. You write your library algorithm to work with opaque types, and when you need type-specific functionality, you call a function pointer given by the user. I guess I see. A good example of this in standard C library is qsort function. For moving things, it just mem copies a void pointer, but for the actual comparison, it calls the comparison function given by the user. Yeah, makes sense. The advantage of this approach is that it takes up very little code space. There is just one qsort. The disadvantages are that it is type unsafe. There is no way to check that the user's function pointer is the right one, and it is annoying to use. Yeah. The user has to define probably trivial global function just to sort some data. Yeah. Inline macros. Another approach is to not define a function at all and just do the work in macro. The classic key and error definition of max is an example of this. Ignoring the multiple evaluation problem, A or B is evaluated twice, which can be expensive or surprising if it involves side effects. This is not adequate for more advanced operations here. So sense extensions you can't really define or use local variables. You can't use recursion. Yeah, you can't get normal compiler error when you pass the wrong type. Yeah, that's the biggest one to the function, and this forcibly inlines the code at every usage site. Yeah, it is very easy to use though. It looks like a function. Yeah, code generating macros. Another approach is to actually generate a function with the actual types. Yeah, and call that generated function. To avoid having to actually copy-paste and generate the function via macro. Combine AB. What the hell is that? Make max t prefix static inline type combine. Okay. These backslashes, they're like so, it's so disgusting. Lol, like how people. Okay, let's just don't cry and just use it. Okay, we then create an int, right, function, int max. I don't see how it like defines the name. Combine. Oh, I see. Prefix max. Yeah, I see. So it's like int is here, max is here, int max, yeah. But it's not really. I mean, it's not bad. This type safe and you get the benefits of functions separating implementation details from usage, local variables, etc. But it becomes impossible to debug if you need to step through the generated code. The nature of C macros is everything will be on a single line. Checking the result of the macro expansion is also more difficult. Additionally, customizing the expanded code is difficult. You either need a large number of arguments to the macro or just forgo customization of things like prefixes to function names. Yeah. Finally, just writing it is annoying. You need a backslash on every line. Yeah, that's like most editors give up on syntax highlighting it properly, etc. Source code generation. Another alternative is to generate extra source files that then are compiled into a program. No, it's like the most like unpleasant, I guess, solution. The issue with this is that it greatly complicates the building and compiling of your code. Suddenly you need a build system that is aware of the need to generate the code instead of just leveraging the C compiler that you already have. You step further away from the ideal of just compiling with copy paste. The manual version of Source code generation is copy-pasting the data structure and function every time you need a new one. It's a nightmare for maintainability. A bug copy-pasted 100 times might never get fixed, especially if that code is then altered and diverges. Yeah. Template headers with multiple inclusion. I guess that's the solution. I hope. This approach is very similar to code generation macros, but with the benefit of it being easy to check the expanded code. It is possible to debug, and customization is much more straightforward thanks to ifdef. The rest of this article will explain how they work. Template headers. The idea of a template header is that you have a file that's meant to be included multiple times. Each time the file is included, it generates a new data structure or new function, new functions, specialized to give type or types, specialized to a given type or types, or really on anything you can imagine. The easiest way to explain this is find an example. Okay, the array.h includes this header multiple times to implement a specific dynamic array. Okay, I guess I kinda see. Before inclusion, define at least the array t to the type the dynamic array can hold. See the array name, the array prefix, and the array linkage for other customization points. If you define the array declarations only the declarations of the type in this function will be declared. If the array header h not defined, define it. Inline functions defines and includes that will be needed for all initializations can go up here. Okay. Define the array temp implementation word, the array combination 1, the array prefix word. Okay. I don't really understand why would you like do it that way, but okay. And if no, this section is not guarded as it is intended to be included multiple times. If not def the array key, error must be defined. Good, pretty good. The name of the data type to be generated, if not given, will expand to something like the array int for an int. Yeah. Okay, prefix. Damn, it looks so ugly, I'm not gonna lie. Prefix for generated functions. Customize the linkage of the function. Okay. Type def struct the array name. What? Oh yeah. It's like, how's it called? Forward declaration or something. Struct the array name. Damn, C is so cursed. The array key items. SSD count, SSD capacity. What that means, like, example usage. Let me see. Include assert stdio, define the array key int, the array prefix I, the array name, int array. Yes, that's a problem, right? It's not generic. Must be manually instantiated by including the file. Good. Int array, ints. I push, ints. And it's gonna be like I get, right? Ints, items. Push, ints, assert, count 6 items. Ints, items, okay. One reason this approach shines is that it is simple to debug this generation of the code. For example, you can simply see. Yeah, but I thought it's gonna be like I don't like have to use like this int array. I would just make it array, you know. And then I just like Yeah, but how I will tell that it's an integer, right? It has to know. The preferred way is to not implement generic collections in C. If the application needs a generic collection, write it in a language which provides generics. This is the way. And these decisions are always so, like, difficult. Array list. It's probably that way. Let's see. Okay. Let me think. What do I need it for, right? What's wrong? I need it for expressions, right? No, expressions are like gonna be 3. I need it for tokens. Yeah, I need it for tokens. Macros in C are pretty much necessary for this type of problem, really. Like stbds, generic list in C, just block, design, header, list. I want like how is it used? Functions, implementation includes, insertion, append, insert. Okay, remove, index of, get and take. Bulk operations, manual sort, next steps. How do you use it? Show me like the interface. Actually, like interface is the very beginning, right? I just have to like spend time interpreting it. Design. We can get around the fact that C arrays are how we need to create dynamic lists. C arrays are how, but we can't abstract them, so we do not get, yeah. Struct list. Type the abstract list, list T. Okay. Int list equal list copy. Damn, it's so type def struct enum callbacks flex functions implementation list void elements double pointer. Interesting. CST allocated allocked CST len. So it's like a capacity, right? No, it's not. Wait. Yeah, it's a capacity. List CBST. What is CBS? List flux. Bulk in bulk. Wow. Let's go to Gemini, and I just hope that it will figure things out. It will understand what I want. Yeah, but it's not really type safe and user friendly, as they always have to specify the type of slice. Is there a way to get the exact semantics, or at least really similar to as in Go? As Go slices have. Generally, to be honest, like Yeah, I'll need macros for that. But like if I'll write it once correctly, it doesn't matter if it's like hard to debug, right? Like I just want to make it really small and just keep it there forever. You're absolutely right, the void star approach achieves the mechanical behavioral goal slice but completely fails on its two most important user facing features, type safety and ergonomic syntax. Yeah. To get much closer to semantics of Go, we need to abandon the single generic void star struct and instead use the C preprocessor macros to generate type-specific code. Yeah. The approach will give us full compile time, type safety, improved performance. Yep. Better ergonomics. It's a macro-based code generation. Generator header. How to use a okay, so it's like full in header because it's just macros. Clear slice type name type. Okay. Yeah, but like, how do you use it? Wait, show me. It's user-friendly made to see. In slice? Where do we get this in slice? Include in slice that sucks. In slice. That sucks. How to use generator now to create slice of ints, you follow the steps. Actually, like, there is like a library which does that, but like when I was reading its code, it was so ugly. Like it was like one big inlined macro, which just. But I want to check it out one more time because like the end result was really good. How do I write it? C array list lib. Library. GitHub. There are like there is like not only a release, there are like more other stuff. There's also hash map. See hash map. What's it called? STB or something? STB? Yeah, I'm not sure. STB single file public domain libraries for C++. Yeah. What's STB stands for? Single file public domain libraries. But why is it STB? Hello, Cool. Hello. How are you doing? Damn, what does STB stand for? I have no idea. What does STB stands for in CLib? Good, and you? Pretty good. Writing the language in C. At least trying. Like, right now, I'm at the point. Like, I made... So I'm going really simple right now, right? So I'm just doing a basic calculator. So I got this 1 plus 2, I got this token with like type and value. I got this simple tokenizer. Right, I got the array of tokens, but I really feel like it's all static right now and I want to make it dynamic. And I don't want to like always use malloc manually. So I want to write a generic array list in C. And for that I have to use macros, and it just feels terrible, but like there is no other way and I don't know how to use macros, so I'm just exploring all of that. Cint Barrett, I guess. Nothing is... It's apparently the screen name of Cint Barrett. Okay. So here we have array. Type say dynamic array. Yeah, yes. Let's go. Dynamic array. Yeah, and here it is. And it's just like so difficult to read. Those are like inline functions, right? It's just so difficult. I want to scale it actually. Oh, I'm scaling the wrong scene. I guess the only way is to like go through it, right? Like what else I can do? I can try to ask AI to explain it for me, but I'm not sure if it will like, if I'll like get through it, you know what I mean? Okay, this is single header file, yeah, table of contents. Yep, compile time options. No short names, okay, I don't really care. License, I don't really care. Actually, I care, meat, okay, good. Documentation. Dynamic arrays. Non-functional interface. Declare an empty dynamic array of a type T. Equals no. Okay, so it's like basically just an array. It's just an array. Oh yeah, I remembered. Yeah, so like you can treat it just basically as an array, right? But under the hood it just makes this like weird scene which creates the capacity and length before this pointer, right? And it's like really weird. Actually, like I recall like how it works, and I feel like fully understanding this is gonna be so difficult. I'll just ask Gemini. I mean, at least I wanna try. Like maybe it's gonna be not the best, right? That's clear. Could you please explain how does dynamic array? How is dynamic actually? How is fuck implemented here? See. Just like that. Okay, now. So we got all these functions. I can actually just jump straight into like declaration. Define. Okay, so it's just like it's TDBS, so it's like a friendly redefinition of the function name, right? String alloc. Okay. If defined CBS realloc and defined, not defined. You must define both. Okay, it's like some error check. For security against attackers, seed the library with a random number at least time, but stronger is better. Rand seed. Okay. But like, oh, it's for hash map, right? It's probably for hash map, yeah. Hash. It's all hash, right? Is it? No. ArrayLen. Here we go, it's an array. This macro takes the address of the argument, but on GCC Clang can accept error values. What the hell is threat value? Address of. Okay. CBS header. Temp key. Damn, it's so unreadable. Like, the fuck, like. Array set cap. Set len. Okay, actually, array push. SDBS array put. Okay, let's go to array put. Where's array put? Let's start with really like SDBS array maybe grow A1 array put A volume. What is A and what is V? Wow. Because it's a classic and very clever C implementation technique, often referred to as a fat pointer or header pointer trick. Let's break down how stbds.h implements its dynamic arrays. High-level concept. The core idea is that the pointer the user holds, key star array, is not a pointer to the beginning of the allocated memory block. Yeah, instead it points to the beginning of the actual array data. Yeah, it is. A hidden header containing metadata. How do you read? It's data, so it's like metadata, right? Like len and capacity is stored in memory just before where the user's pointer points. Yeah. All the API functions, ArrayLen, ArrayPut, etc. are macros that know about this trick. They perform pointer arithmetic to find the hidden header. read or modify the metadata, and if necessary, relocate the entire block. Yeah. I mean, it's really clever, but the implementation just... The metadata header. The first key piece is STPDS how do you... array header struct. This is where the array state is stored. Okay, so we got len capacity, hash table, used by hash map, not the array. Okay, used by the hash map, not the array. Okay, so I don't use this. For dynamic arrays, we only care about the first two. Yeah, so it's like len and capacity, just like in Go. The number of elements currently stored in arrays, the total number of elements the allocated memory can hold before it needs to be resized. Yeah, the memory layout rig. When memory is allocated for the array, DS allocates enough space for both the header and the user data in a single continuous block. Yeah, the user's pointer is then set to pointer after the header. Yeah. Here's the representation. Yeah, so we have this header, which is like before the pointer. To make this work, the library needs two-way conversion. From user pointer to header, given a user pointer A, the header is at, yeah. So we just go back, right? Header. What the hell is this syntax? How do you like interpret it? Array header, pointer. Like what does it mean? Okay, it's like it's because it's a macros or something. It's a type definition. Wait. Why is the parenthesis here? From header pointer to user data, given a header pointer h, the user data starts at h+1. Why not just h? This is encapsulated in the header macro. Okay. Okay, the API macros in action. Now let's see how the API macros uses layout. Array-len. This is the simplest. It gets the header and returns the len field. Okay, I need to drink. Honestly, I need to drink. Damn, it goes hard. I want to re-implement it, right? I don't want to like just use it, because like the thing is, like after creating the language, I'll also have to like rewrite it itself in this language. So, like everything I do, it should be created by myself, right? By me. So it's gonna be much easier to recreate. So I'm doing this, now it's harder, so later it's gonna so later it could be easier, right? We take an A, if A, else 0. Okay, if it's not a null, right? Pointer div t. What does it mean? Like, is it function call? What is that? Header A len. This, if the array pointer is null, then len is 0. Yeah. Otherwise, it uses the macro to find the header and accesses len member. But what is that? It's a type, right? It's a tab coercion, or how it's called. Pointer div. Type, yeah. Okay. Array put. This is the most important one. It adds an element to the end of the array. So we get a and value. Array maybe grow a and 1. Then we are taking the a. Wow, it's so hard to read. This macro uses the comma operator to execute two expressions in sequence. This macro uses, okay, yeah. Array maybe grows. This macro checks if the array needs to be reallocated. Fuck, it's so unreadable. Wow, wow, wow. It's hard for me to read the macros as I don't know the syntax, the amount. The amount of parentheses. How do you write parentheses? Yeah, just like that. Commas and different identifiers. Just really confuse me. The amount, so it confuses, right? It's a growth strategy. And actually I want to branch it. How do I branch it? I can do it while like, it generates. Okay, then I'll just ask it here. I want to ask it to like generate the same scene, but in a more readable way. Of course, it's completely understandable to be confused by C macros syntax, especially a library as clever and dense as SCBDS. It uses several advanced C idioms that aren't common in day-to-day code. Let's break down the syntax piece by piece, starting with the basic okay. The comma operator. This is the most important and unusual feature used here. In C, the comma operator in B does two things. It evaluates expression A, it evaluates expression B. The entire expression AB results in the value of B. Okay. So it like evaluates B and returns the value. It's a way to sneak multiple actions into a place where C expects a single expression. Simple example. Int x printf 5. This will print hello to the screen, assign the value 5 to x. So x becomes 5. Wait, is it like how it works? I can just like use parentheses? It's not even a macro? Wait. No way. Actually, no way. What do I have here? Wait. Call to a declared function tokenize. Oh yeah, my bad. Wait, what am I doing? Make run. Hello. Yeah, it works even without macro. Or is it like macro? You can write macro right here. That's interesting. Okay. The ternary operator. Yeah, I know this one. This is a compact if else statement. Structure, yeah. Built-in block 3 parentheses around macro arguments. You'll see A and V everywhere. This is a standard safety practice in C macros. Macros are simple text replacement. Without parentheses, you can get incorrect order of operations. Okay. Define double x multiplied by 2. Okay. Int result double 3 plus 4. The macro expands to int result here. This calculates, which is wrong. Three plus 8 equals 11. Oh yeah, it is wrong. Yeah, because you expect like this to be done first. Yeah, the save way. I see now. Okay, save double. No, there's like extra parentheses here, isn't it? Oh no, it's like for X and for everything else. Wow, yeah. Okay. Save double. Is correct. So all parentheses are there for safety and to control the order of evaluation. Okay. The constructor is SCB. Relearn. Now let's apply the concept to the actual code. So we got A, it's just like a safety measure, right? This is a ternary operator. If the array pointer A is not null, then do the first scene, otherwise do the second scene, yeah. If A is not null, pointer diff. This is the core trick. It means go to the memory location right before A. It's another function. Macro. Len. Accept the len field from the hidden header. Just cast the result to the correct signed integer type. Okay. Reput. this is a comma operator, it means do the first part and do the second part, yeah? First part. This is another macro whose job is to check if the array has enough capacity. Let's look at its definition. Yes, this one is hilarious. Condition. If not A or len plus n more than capacity. Okay. In English, is the array pointer a null? Yeah. So if it's not 8, it means it's null. Is the array pointer a null, or will add in n, which is a 1 for array put? Yeah, which is like really weird. Why it's 1? Elements exceed the current capacity. If true, we need to grow. Regrow. This is another comma operator. This calls the actual function. It's a dozer realloc. Crucially, this function reassigns A if the memory moves. Comma 0, the whole expression relates to 0, but the important fork going the array has already been done. Okay. If false, we have space 0, do nothing. So stbds array maybe grow A1 means if needed, reallocate the array to make space for one more element. But why only one? Why we don't like check the len of the oh, because it's push and we push only one, right? Repush, yeah, it's only one. It's not like append. It's not append, right? That's the point. Yeah, it makes sense. Makes sense. Second part. Where is it? I don't see it. Oh, is it like here? Yeah. A header len plus plus equals v. This part runs after the array has been resized if necessary. Get the len, eg5. This is the index for the new element. Yeah. Plus plus, the post increment operator means, oh, okay, I see. Use the value further than incremented. So it uses len as the index and then the len becomes 6 here. The value v is assigned to the new slot at the end of the array. Put all together a complete trace. Let's trace a call. Yeah, I mean, okay, now it makes sense. Is there a more simple, human readable way to implement it? Same behavior. Please think through it. Okay, I guess I have to like explicitly say it. Deeply think through it so you can come up with the most optimal approach. Let's go. Excellent question. The CVDS implementation is optimal for a very specific set of goals. Mimic C native array index. This is a primary magic trick. Be extremely concise. The user only needs to manage a single pointer. Be type generic without void pointer class in the user's code. Yeah. This is achieved through macros and size of A. Yeah. The most human readable approach is the explicit struct. The simplest, most readable, and most common way to implement this behavior in C is to stop hiding the metadata and make the dynamic array an explicit struct. You treat the magic of array I for the clarity of array data I. Data structure. The API is simple functions, not macros. Wait, length, capacity, and element size. DA create as dynamic array. I thought it's like da. Okay, we'll create a set of clean, simple functions. The user will pass a pointer to the dynamic array struct to be modified. Okay, the implementation. How to use the readable version. Create an array to hold integers. Dynamic array. My array. Okay, what is dynamic array? Like, where is the type? It's generic, right? Dynamic array. Yeah, so it's always void pointer. Create size of int to push values onto the array. Value. Push value. Yeah, and so like I have to be careful what am I pushing in, right? Always. Comparison readability. Declaration. Yeah. Readability excellent. All state is visible in the struct. Operations are explicit function calls. State is hidden. Operations are macros that modify the user's pointer magically. Yeah. Debugging easy. Hard. Element access. More verbose, yeah. Clean and native, yeah. I like this one so much. Int star p equals get array I int value equals, yeah. What is I? Actually, I have no idea what I is. Oh, it's an index, yeah, I bet. Adding an element. Da push. Reput. Safety. Higher dynamic array struct pointer itself is stable. It's harder to misuse seriously. Lower the user's pointer array can be changed by macros. Yeah, okay, I mean, I see. I see what does it mean. But like, it's more unsafe in a different way. I mean, like, I can put any data inside, not like the ones that is intended to be put in. Which can lead to subtle bugs if you if not handled carefully. Performing slightly more overheady to function calls can be inlined by a good compiler and passing structs by pointer. Okay. Clearly, the most optimal approach depends on your goal. Accessing. P-value. Give a pointer to the element and dereference it. Get a pointer. Yeah, get. I int p-value. If p-value, yeah, print. Pop an element. Popped value. Popped value, new line. Clean up. Okay, I guess I'm gonna stick to this approach actually. And I'll just like upgrade it in my language. But for now, I guess it's enough for today.